Okay, so last section we went over the constant rule, the addition and subtraction rule, the constant multiple rule, and today, and the polynomial and exponential rules. Today we're going to continue with two major rules in section 3.2, namely the product rule and quotient rule, the product and quotient rules of derivatives. Of the derivative. Let's first start with the product rule. The product rule of derivatives. So if f and g are both differentiable functions, that means the derivative exists at every point, functions of x, then the derivative of f times g. So you fix the first function, you times by the derivative of the second, plus you fix the second function, you times it by derivative of the first. And there's a proof for this. To find the derivative, we always go back to the limits, f of x, g of x. Remember, derivative is limit as h goes to 0, f of x plus h, g of x plus h, minus f of x, g of x, all over h. Now, if we add and subtract, if we go in here and add up and subtract the same expression, if we minus f of x plus h, g of x, and then plus the same thing, f of x plus h, g of x. So what's going to happen if we pull these two terms together, and this and that together? Okay, so what's going to happen, we're going to factor out f of x plus h from the first group, and then it will be g of x plus h minus g of x all over h, plus here we can pull out g of x, and then f of x plus h minus f of x all over h. Now if we do the limit as h goes to 0, each one of these, so this would be, if h is 0, this would be f of x, and that's derivative of g, as we know. This is g of x times the limit of x plus h minus f of x over h, as h goes to 0 is f prime of x, and that's the product rule. Okay. So as a shortcut, if we do f times g prime, it's f g prime plus g f prime without the x's and all these notations. Okay, so let's look at a couple of examples. So if y equals x cubed times e to the x. Remember, in section 3.1 we had the constant multiple rule. Like if we have 5x cubed, that's a constant. We don't use the product rule for that. We just say derivative would be, you keep the 5 out, so you bring the 3 down. 3 times 5 is 15, and then you minus 1. That's constant times a function. Here, f of x times g of x. That's how they're different. Okay. So now we must do here the product rule. So y prime, we fix f times derivative of e to the x, fix e to the x times derivative of x cubed, which is 3x squared. And we need to do some tweaking. 3x squared e to the x. Number 4, page 189, y equals 10x squared plus 7x minus 2. We always have a choice here of multiplying it out first, but if we want to do the, why am I doing this? Okay, if we want to do the product rule, we can. So we're going to fix the first one times derivative of the second. I'll just do the rule and then I'll work it out. So prime, that's the derivative, and then fix the second, which is 2 minus x squared, times the derivative of the first. 2 prime. Okay, so y prime equal 10x squared plus 7x minus 2. Derivative of 2 is 0 minus derivative of x squared is 2x, so it's minus 2x plus 2 minus x squared. Derivative of 10x squared times 10 is 20x, and then that's a 1. So x is 7, and then 2 is 0. And then you can work it out, and that's what I got when I worked it out. Minus 40x cubed. It's all algebra now. Plus 40x plus 14. Number 18, page 189. H of w equals w squared plus 3w, and then w to the negative 1 minus w to the negative 4. Again, we're going to do the product rule. Okay, sorry. So the product rule, we fix the first function times the second one prime, plus we fix the second function times the first one prime. fg prime plus gf prime. So w squared is 3w. Derivative of w to the negative 1 is negative 1, w to the negative 2, and that's negative 4 times negative 1 is 4, w negative 4 minus 1 is negative 5. That's fixed. Derivative of w squared is 2w, and 3w is just 3. And if you work it out, you're going to get, if you FOIL, you're going to get negative 1 plus 4 w to the negative 3 plus 3w negative 1. That's a minus. Plus 12w to the negative 4. I FOILed this. And now let's FOIL that. Plus 2 plus 3w to the negative 1 minus 2w to the negative 3 minus 3w to the negative 4. And it ends up being this, 9w to the negative 4. The way these cancel out, and you bring the negative 1 plus 2 is 1, and 4w to the negative 2 minus 2, these two guys gives me this, and then you have 12 minus 3 is 9w to the negative 4. Okay. Alright, there's more examples that I'd like to share with you. So if I have something like this, x squared minus 7x plus 3 over 5. Remember, 5 is a constant. So before we do any derivative, we're going to do the algebra. We're going to divide the 5 into each one of these. So that's 1/5 x squared minus 7/5 x plus 3/5. And then you do the derivative. That's a polynomial function. 2 times 1/5 is 2/5 x to the first. 7/5 times 1, and then that's a 0. Also, if you have a fraction where the top is a constant, before you do the derivative, you want to do the algebra. You write this as 5x to the negative 4, and then its derivative would be negative 4 times 5 is negative 20x to the negative 4 minus 1, negative 20 over x to the first. The second rule of this section is what we call the quotient rule, which can be proved. It's very similar to the product rule, so you can read the proof in the book. The quotient rule, if you're finding the derivative of the quotient of two functions, remember, both have to be functions. If the top is a constant, you don't need to use the quotient rule. If the bottom is a constant, as I showed you in the previous example, you don't need to use the quotient rule. It's a lot easier if you don't use the quotient rule. So g is the bottom, f is the top. So you do the bottom times derivative of the top minus top, and there's a minus, unlike the product rule. Minus the top derivative of the bottom over the bottom square. Remember, there is no derivative at the bottom, okay? No derivative at the bottom. So you start with the bottom, times it by derivative of top, minus top times derivative of the bottom over the bottom square. Let's look at several examples. So if g of x equals x squared minus 2 over 2x plus 1, then its derivative using the quotient rule. Again, we're gonna use the quotient rule because neither the top nor the bottom is a constant. They're both functions of x. So we fix the bottom, we times it by derivative of the top minus top derivative of the bottom over the bottom square, and no derivative at the bottom. So 2x plus 1, derivative of x squared is 2x, derivative of 2 is 0, derivative of 2x is 2, derivative of 1 is 0, so we don't need to do that. And now the rest is algebra. You distribute, so you get 4x squared plus 2x, and then if I can put the 2 up here, minus 2x squared plus 4 over this square, which would be 2x squared plus 2x plus 4 over bottom square. Okay. So that's number 24, page 189. 24, page 189. H of r equals a e to the r over e plus e to the r. Well, it says differentiate. Differentiate. Okay, so r is the variable because it's h of r, a, b constants. Okay, so these are like numbers. R is the only variable in there. So to do the quotient rule, we fix the bottom times derivative of the top minus top derivative of the bottom over the bottom square. So h prime of r equals b plus e to the r, derivative of a is a constant, a times, so r, e to the r is going to be e to the r, so a e to the r is a e to the r minus a e to the r, derivative of b is 0, b is a constant, e to the r is e to the r over b plus e to the r square. So if we tweak it a little bit, you will get a b e to the r plus e to the a e to the 2r minus a e to the 2r over b plus e to the r square. That would be my final answer. Okay, let's look at 38 from page 189. Y equals x plus x e to the x, and we're looking for 38. It says find equations of the tangent line and normal line to the graph at the specified point. So let's first do tangent line. Equation of tangent line to graph of f at 0, 0. So y minus 0 equals m, x minus 0. M, to find m we need the derivative, slope of tangent line, derivative of x is 1. This is product rule, x is a function of x, e to the x is a function of x, so fix e to the x prime plus fix e to the x, x prime. So it would be 1 plus derivative of e to the x is e to the x, derivative of x is 1. So m, so we're doing this at 0, 0, that's going to give me the slope at that point. 1 plus 0 e to the 0 plus e to the 0, so 1 plus 1 is 2, and that's the slope. So we put that in here, we get y equals 2x. Now the normal line, its slope, normal line is perpendicular to the tangent line, so its slope is opposite reciprocal of that slope. Opposite reciprocal would be -1/2, so its equation is -1/2 x. Okay. 46, page 190. Page 190. It says suppose f of 4 is 2, g of 4 is 5, f prime of 4 is 6, and g prime of 4 is -3. We're given all this. It says find h prime of 4. I'll just do part B. That looks the harder. H of x equals f of x, g of x. To find h prime, that's the product rule. H prime of x, so f times g prime plus g times f prime. That's the product rule. So if we're going to plug in a 4, it would be f of 4, g prime of 4 plus g of 4, f prime of 4. So we have all these values. That's a 2, that's -3, and g of 4 is 5, f prime of 4 is 6, and that comes out to be 24. Number 50, page 190. It says f of 2 is 10. F prime of x equals x squared f of x for all x. So these are given for all x. It says find the second derivative at 2. Well, we already have the first derivative, so to find the second derivative, we find the derivative of the first derivative. Product rule, again, x squared is a function of x, f of x is a function of x, so we fix x squared, derivative of this, plus fix f of x, derivative of x squared, which is 2x. So if we want to find f double prime at 2, we plug the 2 in there, f prime at 2, plus f of 2 times 2 times 2. So that's 4, f prime at 2, right here. If we want to find f prime at 2, it's 2 squared f of 2. That's 4 times 10, which is 40. F of 2 is 10, and that's 4. 40 plus 160 is 200. And that's it for 3.2. We'll see you with 3.3.